Let's solve this and graph it on a number line. And how are we going to do it? Well, we isolate the absolute value bars. They're already on one side of the inequality by themselves. We're good to go. Great. Then we're going to drop the bars and solve. Cool. We'll solve that. Then we drop the bars, flip the symbol, change the sign, and solve. And then we'll graph it. Don't make it harder than it is. Okay, we're going to add 1 to both sides. That gives me 6. So 2x is less than or equal to 6. X is less than or equal to 3. Great, good. We're going to add 1 to both sides. That gives me -4. So 2x is greater than or equal to -4. We'll divide by 2, not -2, so I don't have to flip that inequality symbol around. I don't divide by -2, I do divide by +2. I get a -2. And so then, because it was less than, we will draw it with an and. Okay, so deep southern accent. Less than is and. Greater is or. Less than is and. Greater is or. Less than is and. Okay, so then when I draw this on a number line, I'm going to have a 3 here, a -2 here. You don't have to put all the numbers in the middle. And less than is inside. Greater is out. So here goes. From here to here, we'll fill that in, and it's wrong. Ha-ha, let's fix it. Because it's less than or equal to, or in this case, greater than or equal to, we will fill in those numbers. And that's it. So again, drop the bars, or get the bars by themselves, then drop the bars and solve. Drop the bars, flip the symbol, change the sign and solve. Greater is or, less than is and. Greater is or, less than is and. And that tells you which direction to go with it. All right, let's keep moving. Second problem is x minus 4 greater than, let me erase this, but I have. Absolute value of x minus 4 is greater than 3. X minus 4 greater than 3. Okay, get the bars all by themselves. Done. All right, drop the bars and solve. Cool, we'll solve it in a minute. Drop the bars, flip the symbol, change the sign, and solve. Less than is and. Greater is or. And when I do this, I'm pointing at the direction it's going to graph. Less than is and, that's greater. Greater is or. So we're going to add 4 to both sides. We get 7. We add 4 to both sides here. We get 1. It's or. Okay? Because it's or, we will graph outward. Less than is and. Greater is or. There's an exception to that, by the way. You're going to see it in a few minutes. Negative, whoa, not negative. I was looking at that. It's positive. Positive 1. Positive 7 goes out. There we go. We have graphed every solution. And let's check for just a second. I'm going to pick a random number over here. 10. 10 minus 4, 6. 6 greater than 3? Sure. Let's pick a number over here, like 0. 0 minus 4 is -4. We absolute value it. We get 4. 4 is greater than 3. It works. So we have graphed the actual solutions. Notice I didn't fill in the circles on those because they weren't equal. All right. Let's keep moving. Next problem says absolute value of x plus 5 is greater than or equal to 2. Now, if you are watching this, then you're probably at a point where you could try these on your own, so I recommend you mute the video, try it on your own. So, get the bars by themselves. Check, they are. Drop the bars and solve. Cool. Drop the bars, flip the symbol, change the sign, and solve. Less than is and, greater is or. We'll subtract 5 from both sides, and that gives me -7 here. We'll subtract 5 from both sides. That gives me +3 here. Whoop, 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 -3 here. And then we will put them on a number line. Just put them in numerical order. Usually that one's a smaller one, depending on how you set this up. And less than greater. Or goes outward. There we go. Or is out. Or outward. See, they start with the same letter. That's how you remember it. Okay, the next one is not much trickier. It's actually just one extra step. So let's do this one. We have 4 times the absolute value of x plus 1, and that is less than 12. Okay, step 1, get the bars by themselves. Okay, let's do it. Let's divide by 4. Cancel, cancel. X plus 1 is less than 3. Bars. So now we're ready to start the problem. And it's the same process. So we just had one little thing to do before we started. We just divided by 4. So drop the bars and solve. Drop the bars, flip the symbol, change the sign, and solve. So subtract 1 here, gives me 2. Subtract 1 here, gives me -4. Less than is and. Greater is or. This was less than, so was that one. So this is and. That's the one I need to look at though, not the original, because if, this is worth saying here, if I would have divided by a negative, that would have flipped that symbol around, and then I'd be dealing with a greater, which is or. So -4, 2, and goes in between, so we'll put a circle, and is inside, and they should not be filled in. That one looks like it is. Now it's not. There we go. Okay, so we have like 4 more problems that are really good practice that I recommend you just try them on your own. I am going to go through them just so you can follow along if necessary, but there's really not that much different about them from the ones that you've already seen. So 4 problems very quickly. I may not even talk much, so try them on your own or mute the video or speed through it, but do try it. Sometimes when we get to one like this, we're so used to the harder ones that we forget how easy they can be. So, drop the bars and solve. No solving to do there. Drop the bars, flip the symbol, change the sign and solve. Less than is and. -4 to 4, circle, circle, fill them in, color in between. There's the first one. We'll switch colors, it's for fun. Absolute value of x minus 5 is greater than or equal to 3. I will have to fill in my circles on this one. Okay, so drop the bars and solve. Drop the bars, flip the symbol, change the sign, and solve. And when we do that, we are going to add 5 here. Said I wasn't going to talk much. I've glanced ahead at the next 2 problems, and I do need to talk about those. So if you're ahead of me, you're probably realizing something is drastically wrong. And you might be right that it's wrong. Greater is or, that goes outward. There we go. So we'll shade out this way, and we do fill that circle in because it's equal, and we'll fill that in. There we go. Okay. The next 2 actually are very different. And if you're trying these on your own, you might be running into a couple problems, and that is okay. So you've probably perked up by this point if you're doing these on your own and you're at the next one and you're like, wait, something's not right here. X minus 5 greater than -3. So we'll just start it the same normal way we've been doing it. So drop the bars and solve. Drop the bars. Flip the symbol, change the sign. Oh, now it's going to change the sign. And then we solve. That's an ugly 3, I know. So we add 5. So x is greater than 2, and x is less than negative, whoa, positive 8. I was doing a different operation in my class, in my head. And we're going to do an or here. And we're going to have kind of a problem with this. It's weird. All right, so here goes. Normally the lower one goes on this side, but now it's up here. So 8 and then 2. And I'm going to graph everything greater than 2. Now, I told you or goes this way, so you might be tempted to be like, oh, I'll go out like this. This is the exception. So I would normally, let's switch colors. It's for fun. I would normally go here, and then I'd go here. And the word or means graph where you see at least one of the little practice graphs. So basically, like if it satisfies this condition or this condition, you're good to go. So you would really shade this. You'd shade that. You would even shade 2 because that graph does exist at 2. And you'd shade here. You'd graph 8 because that graph exists at 8. And then you'd shade the whole thing. And I know you're probably thinking, well, but I thought you told me that you're only going to graph like this if it's greater. And yeah. Maybe. But let's think about the original problem logically. Okay, absolute value is greater than a negative. I'm ignoring the numbers, right? Absolute value is greater than a negative. What does absolute value do? It makes things positive, or 0. So it's going to be 0 or positive. Are positive numbers greater than negative numbers? Yes. Always. Is 0 greater than a negative number? Yes. Always. So if I'm thinking of numbers that I can plug in here that will work, any number I try will work. Any number. Any of them. Give me a number. 12, thanks. 12 minus 5, that's going to give me 7. 7 is greater than negative 3. Sure, great. Any negative 1 million, negative 1 million and 5. Make it positive. Positive 1 million and 5 is greater than a negative. Any number you try is going to work. And looking ahead, oh, by the way, let me write the answer a little bit differently. We could say all real numbers as opposed to fake numbers, well, as opposed to imaginary numbers, which do exist. All real numbers are solutions. You could also graph the entire number line. Okay, let's do the same problem, only it's not the same problem. We're going to flip that inequality symbol around because that's what the next problem is. And we're going to encounter a different type of problem. So we'll start it the same normal way, just in case you didn't notice that this problem is a little different because of the negative over here. That is the difference. It's the negative on this side. So x minus 5 is less than negative 3, and x minus 5 is greater than positive 3. So x is less than 2, and x is greater than 8. And let's put the word and in there, just because we should. So 2, 8, and then we're going to kind of draw some graphs here. And I think I told you this earlier in the lesson, but and means you find out where they meet, like their intersection, which is normally in the middle, not in this case. So I want to graph everything that's less than 2. I want to graph everything greater than 8. And I want to graph where they meet. They don't meet. One's going this way, one's going that way, and they never cross paths. So this actually is no solution. And that makes sense. Let's go back to the original. Absolute value is less than a negative? No. Absolute value is always going to be positive or 0. So 0 is always going to be bigger than a negative, but this says it's less. That doesn't even make sense. So any number you pick, 12, 12 minus 5, 7, 7 is less than negative 3. No, it's not. So I can't graph that. I can't graph any number. No number I plug in here will give me a true statement. If we went back to the very beginning of the lesson where we made all the little tables and we're like, hey, find this one, is it true, is it true? Nothing would be true, and we'd graph nothing, okay? So the difference between the regular problems and then these last two problems that gave us these wacky solutions was the fact that when we had the bars by themselves, we had negatives over here. So just be aware of that. Whether or not it's positive, whether or not it's greater than a negative, that'd be all solutions, or less than a negative, which would be no solution.